Dr. อิสระชนะแก้วสมบูรณ์ am coordinated lecturer from Prince of Songkhla University. For our class today, I would like to introduce Associate Professor Dr. Herma Dina Setiabudi from University Malaysia Pahang. Professor will discuss in the topic of role of catalyst development on the sustainable chemical process. We quite lucky because Professor she expert in catalyst. Our students who attend our class today, please focus and exchange your idea with Professor. And for our class today, I have another big meeting with my management team. So I assign Sutipong to conduct to help Professor on class. Thank you, Professor.
Thank you very much, Isara, for the introductions. Okay, so Sutipong, I would like to check how many students from the PSU for today's sessions?
Six.
Six.
Yeah,
So currently only you, and I can see that Sarish Batara, is it from the PSU?
Yeah, actually I got this email, but I don't know why. So I am in PSU doing PhD program here. I'm from Nepal.
Okay, so you are currently what topics that you are doing for your PhD? What field?
I'm in energy management faculty.
Energy management. Okay.
Okay, so my topic is sustainable heritage management, and through energy, how to sustain the heritage and connecting people, community, and that is my topic.
Okay, so you are dealing with the renewable energy, or what types of the energy?
Renewable energy. I'm focusing, and my advisor and Dr. Kunan and other are focusing. Dr. Montre are focusing in wind energy.
Oh, wind energy. Okay. Okay, so Sutipong, I would like to double check. Should we wait for a while for other students, or we can continue? Because as you mentioned that the total number of the students from the PSU is 6, so currently only 1. So should we wait for a while or what?
Professor, you can continue class, and then I will send link to student for
Okay, sure.
if they attend late. Thank you, Professor.
Okay, thank you, Sarah. Okay, before I proceed, I would like to double check with all of you. Did you see my slides regarding the roles of the catalyst developments? Anyone can confirm?
Yeah, is it visible?
Okay. Okay, so good morning to all of you. As per mentioned by Dr. Isara, I'm Associate Professor Dr. Herma Dina Setiabudi. So actually, I'm from the Universiti Malaysia Pahang, Malaysia. So as given and as per discussed with Dr. Isara, my topics for today is regarding the roles of the catalyst developments on the sustainable chemical process. So for this program is actually the Prince Songkhla University 2022 Visual Visiting Professor Program. Okay, so a little bit info of myself. So for the introductions, actually, I'm from the Faculty of Chemical and Process Engineering Technology from Universiti Malaysia Pahang, Malaysia. And then this is some info of myself. I'm graduated from University Technology Malaysia in 2013. And then after that, I'm appointed as a senior lecturer at Universiti Malaysia Pahang. And then regarding the management post, previously I'm the head of reactions cluster. And then after that, I appointed as a deputy dean of the research. And then the previous year, I'm as a deputy director for rankings and branding divisions. And currently, I'm the director for the ranking and sustainability divisions. So for today's sessions, I would like to share a little bit about the sustainability and about the catalyst. So as mentioned here, that my expertise is basically on the reactions intensifications. I'm doing on the reforming, isomerizations, some parts of the crackings, and also the photocatalysis. And then I'm also doing on the advanced materials, on the metal-based catalyst, mesoporous silica, nanosilica, and nanoparticles. And then on the sustainable energy, hydrogen and syngas, and also some parts of the wastewater treatment, in which is the adsorptions and also the photocatalysis. So this is some of the publications, records on the catalyst, implementations in various types of the chemical reactions. So as mentioned that I'm doing some parts of the reactions intensifications, for example, reforming reactions, isomerization, CO2 photo conversions. And so for today, I will share a little bit about my experience and my knowledge on the catalysis, catalyst preparations, and also the roles of the catalyst in sustainable uh, productions, chemical productions. Okay. Okay, so for today's sessions, actually we have two parts in which from the morning sessions we will cover on the roles of the catalyst, developments in sustainable chemical process, in which I will cover on the roles of the catalyst developments in sustainable chemical process, and I will discuss about the recent research and publications in catalyst developments. So for the morning sessions, we have 2 hours. So we will discuss on the roles of the catalyst, and then we have a break around 1 hour, and then after that we will continue on the second part, more on the preparations of the manuscript, and then we will do some class activity in which we will do some short discussions among the team members for the activities related with the manuscript preparations. Okay, so let's continue to the part 1. Okay, so regarding the rules of the catalyst developments in sustainable chemical process, so I will touch a little bit about what is the catalyst, what is the catalysis, and what is the sustainable chemical process. So for those who are not familiar with the catalyst, you will know the purpose of the catalyst itself, what types of the catalyst, and how the catalyst will work in the chemical reactions. So in the small image here, we can see that the graph of the energy with the progress of the reactions. So we can see that actually when we dealing with the chemical reactions, we converting reactants to the products. Okay, so without the catalyst, we have certain amount of the activations energy. But after applications of the catalyst, we can reduce the activations energy, so we can save lots of the energy generations, any energy utilizations, and fast the chemical reactions. So for the catalyst and catalysis, for those who are not familiar, what is the catalyst and what is the catalysis? Catalyst is a substance that increase the rate of the reaction. So when you are dealing with the chemical reactions, you will have the rate of the reactions. But interestingly, catalyst catalyst can convert the reactions, but the catalyst itself will remain as it is, in which catalyst will not consume during the reactions. Only the reactions or substance or reactants will be converted during the reactions. So the second one, regarding the catalyst classifications. So actually there are several classifications that we can make on the catalyst. The first one based on the physical state. Okay, so for the catalyst, we can divide it into or identify based on the gas, based on the literature, based on the liquid, and also based on the solid. So we have three phase in naturals. So the catalyst can be in gas, can be in a liquid, and also can be in a solid. So based on the substance from which a catalyst is made. So either they are made from the inorganic materials. So if it made from the inorganic materials, such as the gases, metals, or metal oxide, or any inorganic acid, it will be called as inorganic catalyst. But if it made from the organic acid like enzyme, so we can call it as a organic catalyst. Okay, so that's the difference between inorganic catalyst and organic catalyst. So another way, we also can identify or classify the catalyst based on how it works. Okay, so if it works as a homogeneous nature, so that homogeneous, we can say that catalyst and also reactant and also the product produced are in the same phase. For example, you converted gases, your reactant in the gas form, and then your catalyst in the gas form, and then the products in the gas form, or your catalyst in the liquid form, the product, and also the reactant in the liquid form. So it's called as the homogeneous catalysis. But if your catalyst, for example, in solid form, and then your reactant in the gas form and your product in the gas form, so you can have different phases, okay, between the catalyst and also the product and also the reactant. So here we can call as a multi-phase or heterogeneous catalyst. Okay. So we also have the classifications based on the catalyst actions. So either is a acid base, enzymatics, photocatalysis, or electrocatalysis. Okay. So for the catalysis, we can identify the catalysis. There are three aspects of catalyst actions. Okay. So the catalyst itself, it can be taking part in the reactions. Okay. So actually catalysis, it will change itself during the process by interacting with other reactant and product molecules. So your catalyst will react, or not will react, will play important roles to initiate the reactions. Okay, to initiate the reactions so that your reactants can be uh, converted into the product. So, catalysts can also alter in the rates of the reactions. As I mentioned before, that for the reactions, chemical reactions, we have rate of reactions. So the roles of the catalysts, altering the rate of reactions by lowering the rate of the reactions, so that uh, we can convert the product, the reactant into the products. Okay, and then by we reduce the rates of the reactions. Okay, so at the same time, catalysts also play important roles to increase the conversions, to increase the selectivity, so that when the catalysts play important roles in increasing the selectivity, so therefore they will reduce the undesired reactions and also the undesired product. Catalyst also can returning to its original form. As I mentioned, that catalyst will not converting to play in roles in converting the reactant to the product, but catalyst will be there and not being consumed. Okay, so it will return to original form. After the reaction cycles, a catalyst will exactly the same nature in the reborn. So that's why normally the catalyst can be used a few years uh, to up to how many years. Okay, so because the catalyst itself, it cannot be consumed, So, and it always in a original form after the reaction. So that's the interesting of the catalyst. Okay, regarding the solid catalyst, normally for the reactions, we prefer the solid catalyst because when we are dealing with the solid catalyst, the catalyst in the forms of the solid. So when the catalyst in the forms of the solid, and normally our reactant in the gas form or our reactant in liquid form, so it's more easier for the separations process. Okay, so that's why for industrial purposes, they are prefer to use the solid catalyst instead of the liquid or gaseous catalyst or any homogeneous types of the catalyst because they are having a problems during the separations of the process. So for the solid catalyst, actually there are several parts, okay, several elements. We can have the active phase. So the active phase, we can consider that where the reactions occur. So active phase is play the responsibles to initiate, to activate the catalyst, to activate the reactions. So mostly the active phase can be the metals or the metal oxide. Okay, and then the promoter, normally the textural promoter, and then it normally support as a supports or in helping increasing the activity of the catalyst. And then for the support itself, normally it increase mechanical strength, increase surface area, and also may or may not be catalytically active. So it's only for the support. So if you can see from this diagram, so for the catalyst, normally we have the promoter, and then we have the active phase, and we have the support. So these all three elements, three important elements in our catalyst. So these three phase play the important roles in the reactions in which the active phase will play to activate the catalyst. Promoter, for example, if the reactions consist of the productions of the side product. So normally the promoter is helping or play in important roles in reducing or inhibiting the side products of the reactions. Meanwhile, the supporter is normally used as a support for the active phase. For example, active phase is the metals. So for our support, normally they are having the high surface area, so that if you are having the metal, so it can be distributed uh, homogeneously on the support. Okay. So for the general requirements for a good catalyst, we can see that it's very important the catalysts that have high activity, in which the catalyst being able to promote the rates of desired reactions. So normally for the chemical reactions, we have the main reactions, we have the side reactions. So the side reactions is normally the undesired reactions. So it's good to have the catalyst that prefer on the main reactions and reduce the undesired reactions so that we will have the higher selectivity or higher activity. Okay, so for the second one, we need to look on the selective or selectivity. So the catalyst must have a good selectivity or selective towards the desired product or desired reactions, so that they can promote the rate of desired reactions, so they can increase the number of the desired product, and you will have the higher purity of the product. And the third one is regarding the stability. Okay, so for the stability, for the catalyst, it must have you need to have a good catalyst in which the catalyst can resist to deactivate. Okay, so the major problems of the catalyst is about the deactivations of the catalyst, because for the normals or the good one is the catalyst that can be used many times. So if the catalyst have high deactivations rate, so the number of the reusability will decrease. So and it's not good for the industrial scale. So normally we will for the research purpose, we will check on the activity of the catalyst, selectivity of the catalyst, and stability of the catalyst. We will confirm all three elements either in activity, selectivity, or stability of the catalyst in a good and it almost similar with the conventional catalyst. Okay, so this is the three elements and also the important requirements for a good catalyst that need to be considered during the selections of the catalyst for the industry. And also, if we are dealing a research on the catalyst, we need to have a good catalyst, so that catalyst having all these three general requirements. Okay, so let's focus on the solid catalyst. Okay, as I mentioned, that's for the solid catalyst, they must have the promoter. The promoter is optional. Sometimes it's enough with the active sites and also the support. And then because the active site is the phase that initiates the reactions. Okay, so the support is the one that responsible for dispersions, homogeneous dispersions of the solid site on the surface of the catalyst. So for the support itself, there are several common support or carrier materials that normally used in a research or in industry. Okay, so the first one is alumina. Sorry. So the first one is the alumina, because the alumina is inexpensive, and then the surface area is around 1 to 700 milli per gram. Okay, so sorry, meter per gram. So for this one, the alumina is normally in acidic form. Okay, and then for the silica normally similar. It is inexpensive, and the surface area around 100 to 800. Okay, and another type is that commonly used is the zeolite. It's a mixture of alumina and silica, and then it's often exchange metal ion presence and the shape selective. So this is that's why some reactions they are using the alumina, because the alumina is in an acidic form. Meanwhile, the silica is normally natural, and zeolite is depends on the compositions of the silica and also alumina. When the compositions of the alumina is more higher than the silica, it's most probably that the zeolite is in higher amounts of the acid sites in comparison with the alkaline site. Okay, so normally it depends on the reactions. Okay, so if the reactions uh, need to have the alkali side, so it's good to have the alkali types of the catalyst. Meanwhile, for if the reactions require the acidic, so it's good if you can choose the acidic types of the catalyst. And then actually there are other supports that used for the reactions. For example, the active carbons, and then we have the titania, and then we have the zirconia, and then we also have the magnesia and also the lanthanum. So for the industrial applications, this is several shapes of the catalyst that commonly used and available in industry. So it depends on the applications, and you can have these types of the solid support in different types of the shape. Okay, so you can see that this is the biggest size, and then in terms of the granular, in terms of the hollow types. So this is all the different shapes of the support that you can purchase from the industry. Okay. So and then why I'm saying that is very important to the first one, you need to check on the either is acidic or either is alkali. Okay. The second one is normally they consider the porosity of the support during the during the selections of the support. So for examples, you can see from this image, okay. So this is like say your support, and then your support is a porous solid, and then when it's a porous solid, so your support will have a pore. So it's good to have a porous solid support so that your metals or active site will contribute homogeneously or will contribute on the surface and also inside the pore. Okay. So it's also good to have the small active site so that the small active site can distribute well on and also the inside the pore. Okay, you can see that this is the surface of the support and then this is the pore of the support. So all the matter distributed well on the supports and also the insides of the support. So if you are dealing with the reactions, for example, the gas reactions, so the gas will flow like will go through the surface and also the pore of the catalyst. So when you have the active side on the surface and also inside the pore, so actually there are high number of the active site um that responsible for the reactions. Okay. And then so normally for the research itself on the solid catalyst, there are several types that normally uh be focused. Okay. So for example, the first one on the preparations of the catalyst. So mostly they will do the proper selections of the support. They will do proper selections of the solid, and then if needed, they will do the proper selections of the promoter. So during the preparations of the catalyst, they will have the preparations, a lots of the methods for the preparations itself, and then after that, we'll continue with the drying and then also the calcination. So it depends on the procedure of the catalyst. Okay, some of the catalysts require the reductions, some of the catalysts not require the reductions. Okay, so it depends on the purpose or the chemical reactions that need to use. Okay, so there are here you can see that the preparations of the catalyst is normally is you prepare, and after that you try, and after that followed with the calcinations. During the reactions, the catalyst will be reduced because some of the reactions they require the metal sites. So metallic sites, normally after the calcinations, that sites in a oxide form. So if your reactions require the metallic side, so your catalyst need to reduce first, okay, before it can be utilized for the reactions. Okay, so if you are um for the catalyst itself, okay, here let's see on the activity and time. So we can see that for the catalyst, they will have the normally they will have a starting here increasing a little bit, and then after that they constants. So increasing a little bit or decreasing a little bit here, normally this is called as unstable durations because at this time is called as the induction period, in which either is some reductions or some increasing. So for this one is called as the induction period. So after at a certain time, it will it will constant, and it will call as a normal use. So the catalyst will at the constant activity for a long time uh, until the catalyst death, in which during the during the reactions, chemical reactions, normally there are having the deactivations, okay, but it's a slower rate. So you can see that the catalyst in a normal use, so they constants, but you can see that it's a little decreasing in the activity until at the end the catalyst will the use of the catalyst ended that. So in that case, some of the catalyst can be regenerated, in which at certain time after we detected that the catalyst decreasing in activity. So if the catalyst has the possibility on in reactivate, okay, after with the some procedure, so most probably we will reactivate back. But if the cost for the activations is higher in comparison, they're replacing the catalyst. So some industry they more on dispose the catalyst, change the catalyst to the new one. So actually it depends on the catalyst and depends on the reactions in the industry. Either the catalyst can be reactivate against after certain times, or they will use until the end, and then uh, at that time they will change with the new catalyst. Okay, so I will proceed with the applications and roles of the catalyst. So for here, actually there are a lot of the applications of and roles of the catalyst. Since the importance of the catalyst is to increase to increase the reactions, in which they lowering the activations energy. So we can see that there are a lot of the positive advantage or advantages of the catalyst in the chemical reactions. So for the applications of the catalyst, there are lots of the applications in the industry. For example, the industry applications, we can say that almost all chemical industry have one or more steps employing the catalyst. So either the industry only use the one reactor that having one reactions dealing with the catalyst, or actually there are lots of the reactor that using the catalyst for the chemical reactions. Okay, so we can say that almost all the chemical industry using the catalyst. Okay, so actually the catalyst can have a better process because in terms increase the activity and also the selectivity of the catalyst. So the introductions of the catalyst, it can promote the better process economics and also the productivity, in which when you applying the catalyst, it will increase reactions rate. So when you increase the reactions rates, automatically you will speed up the reactions. Okay, and then once you speed up the reactions, you will reduce the time durations for the productions. So normally for the reactions, they needs the energy. So when you increase the reactions rate, reduce the time, so automatically you will reduce the cost uh used to produce that product. Okay, and then it's also sometimes used for the simplify the reaction step. Okay, with the catalyst, normally for the chemical reactions, there are lots of the step in converting one reactant to another to desired product. So sometimes with the applications of the catalyst, you can simplify the reaction step. When you simplify the reaction step, so actually it's more economical. So you can it can reduce the cost of the productions uh, in the industry. Okay, so the third one is the reactions under mild conditions. So as I mentioned that productions of utilizations of the catalyst, they reduce the activations energy, and then they speed up the process. So and also actually they the catalyst reduce the activation energy, actually the reactions can be conducted under mild conditions. So normally the catalyst conduct the reactions conducted at high temperature or at specific pressure. Okay, so by applications of the catalyst, actually you can reduce the reactions conditions into mild conditions, and the temperature is a little bit low in comparison with the reactions without the catalyst. And then also the catalyst apply on the reducing the waste. Okay, so we can improve selectivity towards desired product by the applications of the catalyst. When we improve the selectivity towards desired product, so actually we reduce the amounts of the raw materials, and then we also reduce the unwanted waste. Okay, so during the reactions you will have the reactant, and then the reactant converted into the product. So when you have the high selectivity, actually you can reduce the number of the raw material in order to produce the uh, specific amounts of the products. Okay, and at the same time you can reduce the unwanted or undesired products, and normally is good because you will have the high selectivity or high purity of the product. And then the second one is replacing harmful and toxic materials with readily available one. Okay, so sometimes in industry the productions of the the side product or the side reactions or unwanted reactions, they are harmful to the environments. So by applications of the catalyst, we can modify the bits the reactions routes so that we can reduce the or eliminate the side product. So at the same time, automatically we can select on reducing on the toxic materials or harmful materials produced from our reactions. Okay, so by applications of the catalyst, also it can produce certain product that may not be possible without catalyst. So some of the products maybe without the catalyst, it cannot be converted. Okay, for example, so you have the reactants, and then the reactants need specific temperature, maybe extreme temperature, extreme pressure. So that one is without the catalyst. So it's not possible to have the product because in the industrial skills, normally we avoid to have the extreme temperature, extreme pressure because the safety. So when applying the catalyst, so you can reduce the activations energy, and then automatically you can reduce the conditions for the temperature and pressure to the mild conditions so that you can produce the product that you have that you want. Okay, and then these applications of the catalyst also encouraging applications and advancements of new technology and materials. So in a chemical process, when we are dealing with the main reactions, when we are dealing with the side reactions, so normally the trends of the catalyst developments on improving the reactions processes always in, increasing year by year. So actually we open the advancements of the new technology in terms of the reactor itself, in terms of the materials itself for the chemical reactions in the industrial scale. So apart from the industrial applications, actually catalysts also play an important role in the environmental applications. So for examples, catalysts can play a roles in the pollution control in combinations with the industry purposes. So normally for the pre-treatments, so it's reduce the amounts of the waste or change the compositions of the emissions. So and also with the applications of the catalyst, we can use alternative materials so that we can have an options to have different routes of the reactions by ensuring that the route that we are selecting can decrease or can eliminate the toxic the toxic or unwanted product. Okay, so automatically we can control the pollutions, okay, in chemical reactions and also in any fields of the environmental applications. And then for the examples number 2, in terms of the pollutions reductions, normally we also use catalysts. In terms of the gas, normally for converting harmful gases to non-harmful one. So we normally here, for example, the current trend, I can say that uh, on the CO2 absorptions. Okay, so currently industry looking at the good materials for the absorptions of the CO2. So because we know that currently the topics about the sustainable worlds. So at industry have a certain limit on the releasings of the CO2. So that's why they are now they are looking on the suitable materials for the or suitable methods on the CO2 absorptions, because CO2 releasing CO2 is harmful for the environment. So instead of in terms of the gas, it can be in the liquid, it can be on the solid. So for the gas, normally for the converting harmful gases to non-harmful gases, and then for the liquid, we can depollutions and then decoloring. So for examples, they are using the catalyst for the converting the dyes. Dye is a toxic elements. They converting to the toxic elements. Okay, so they are using the catalyst and then they are using the photocatalysis reactions. So this is all the types of the applying the catalyst. So that actually they are with the aims of the pollutions reductions or pollutions controls. So other types of applications in the solid fields, for examples, they are used in a landfills and also the factory wastes. So there are a lot of the applications for the catalysts, not on the industrial chemical reactions, but also in the fields of the environmental applications, environmentals, and other types of the applications. For example, here we have the catalysis and catalysis play one of the key roles in new technology developments. So we can now we can see that not only for the chemical reactions, there are lots of the fields applying the catalyst to improving the process. Okay, so this is some of the examples of the applications and roles of the catalyst that I can combine for the some info to all of you, for those who are not familiar with the catalyst. Uh, so that here you know that the catalyst play important roles in our daily applications, industry applications, either industrial applications, environmental applications, or other applications. Okay, let's focus on the catalytic reactions process. Okay, so as I mentioned that the catalysts play important roles in the catalytic reactions processes. So for examples in the applications of the catalytic reforming, so this is the flow of the plants of the catalytic reforming. So we can see that there are fixed bed reactor. Okay, so so for the fixed bed reactors, of course, they are using the catalyst. So that's catalyst play important roles to converting the reactant to the products. So for the catalytic reforming, this is normally this is an important process in petrochemicals in refining. So for the petrochemical refining, they will have the catalytic reformings. Okay, so it is the chemical process of converting petroleum refinery from crude oil into reformants, okay, which have a higher octane number in the presence of platinum containing catalyst. So in the reactor, fixed bed reactor, they are having the platinum containing catalyst. So these catalysts play important roles in catalytic reforming. So you can so this is the applications of the catalyst in the industry for the catalytic reforming. The second examples is the catalytic cracking. So this is the systems industrial skills of the reactor system. So you can see that for the catalytic cracking, there is a actually there catalytic cracking is a process whereby high molecule weight hydrocarbons are converted into more valuable gasoline, olefin, and other useful product. So, for example, we have the high molecule hydrocarbons, okay, and then they crack the high hydrocarbon, molecule hydrocarbon, to less molecular hydrocarbon. For example, they crack into the gasoline, they crack into olefin and other useful product. So normally, this process in the industry, of course, they are having the with the presence of the catalyst, and then the catalyst is very important to ensure that the reactions perform at suitable conditions and temperature, and also the pressure. So it's a thermal decompositions of heavy petroleum hydrocarbons in the presence of the catalyst, and then normally it is an ionic process involving carbonium ions, and then normally it will give the higher yields and higher octane number. So for examples, when you are dealing with the fuels, so for the you are normally around 95, around 97, so it's dealing with the actually it's dealing with the higher octane number. So this process play an important roles on the productions of the fuels. Okay, so when they are using the proper catalyst, proper conditions, so it will give the higher yields and higher octane number of the fuel. Okay, so this is the second applications of the catalytic reactions process in the industry. Okay, so let's see another examples, which is the alkylations. So for the alkylations, this is a process whereby light hydrocarbons such as propane, butane, and isobutane are combined. So by using the alkylations, normally the light hydrocarbon they are combined, um, and then uh, normally they are using the catalyst in order to form the high octane petrol. So in the chemical industry or in the petrochemical industry, normally we have the crackering process, we have the alkylations process. This is all the types of the reactions available in industry. So for the alkylations, this is the examples of the process that available in industry. Either they are using the sulfuric acid alkylations or they are using the hydrofluoric acid alkylations. This is types of the applications. Okay, so alkylations is the normally is a process of producing high octane fuels component by the combinations of the olefins. So there are we have the several types of the olefins for propane, butane, and we combine it to form the high octane petrol by using the alkylations process. So it can be either sulfuric acid alkylations or hydrofluoric acid alkylations. So this is all the reactions process that available in industry. For the applications of the uh, industry applications. Okay. Okay, so before we proceed with the recent research and publications in catalyst developments, so maybe we can have a Q&A sessions if you have any questions regarding the general informations about the catalyst, catalysis, and about this types of the catalyst. Before we go through some of the review article, we go through some of the research that dealing with the catalyst developments. So is there any questions from the students before we proceed with the recent research and publications? Okay, do you have any questions? Okay, everyone okay with that? Okay, so if there is no, okay, let me check in the chat room if there are any questions regarding this. Okay, so if not, can we proceed with the another second part for this morning sessions? So for the after some introductions about the catalyst, catalysis, and applications of the catalyst in the chemical reactions, I would like to focus on the recent research and publications in catalyst developments. Okay, so for this part, I will go through some review articles that combining, because the review articles they are discussing on the recent research and publications in the catalyst development, so we can discuss a little bit about that. Okay. Okay, so for the first case study is about the catalytic CO2 conversions. So actually, this is one types of the reactions that currently lots of the researcher focusing on these topics, because currently we are at this stage of CO2 is hazardous for the environment. So because it will affect the global warmings and everything. So that's why current topics they are converting the CO2 into other valuable products. For example, the hydrogens, the syngas. So they apply the catalyst, normally the solid catalyst, for the conversions of CO2 to other products. Okay, so based on this case study, okay, we know that CO2 has become as a focal point of interest because of its positions as the primary greenhouse gases. So the utilizations of the CO2 is becoming an important subject for both academics and industry's perspective. So you can see here that the applications of the CO2 increasing year by year on the research and numbers of the publications. So we can see that from starting from the 2000 to 2017, actually this until the 2023, we can still have an increasing trend for the numbers of the publications regarding the CO2 conversions. Okay, so there are several types of the methods employed for catalytic CO2 conversions. We can see from this graph, we have the CO2 reformings, we have CO2 hydrogenations, carboxylations, electrochemicals, photocatalytics, and solar thermochemical splitting. So this is all types of the CO2 reactions that's currently studied by the researcher. And then among others, among these types of the methods available nowadays, actually the CO2 reformings of methanes has attracted considerable attentions, in which by using these reactions, they converting the Ce2 um, to the to produce the syngas. Okay, so they're converting the CO2 to the syngas, and the syngas actually the compositions of the hydrogen and also carbon monoxide. So they converting the CO2 and also the CH4, CO2 and also and CH4 is the gas that contribute in global warming. So by using the CO2 reforming of methane, we can convert these two gases into syngas, in which syngas consists of the hydrogen and carbon monoxide. Okay, so these productions of the syngas with specific ratio can be the products for generating other useful outputs of chemicals, Either it can be used in the electrical fields or the productions of the methanols, olefin, and ammonia. That's the focus of the current researcher, whereby they are focusing on the CO2 reforming of methane. Because CO2 reforming of methane, we are utilizing two greenhouse gases and we converting to the valuable product, which is syngas, that can be used as a reactant for other products. And then however, for these applications, there are still no progress for commercializations, but currently they are still on the early stage. So several attempts has been made on the pilot scale of trial reforming of process. So normally, currently for the reactions, they are using the steam reforming reactions, though. So they are at the stage of seeing the possibility how if they change the steam reforming process with the CO2 reforming process, and how about the application in the industry. Okay. And then for these types of the reactions, there are numerous types of the recent catalyst developments. So similar with the other types of the reactions, this reaction CO2 reforming of methane, they having the main reactions in which trial reformings of methane, and also the side reactions. Side reactions can be reverse water gas shift, or we know as a RWGS, and then also the compositions of the methane, these proportions of the CO2, hydrogenations of the CO2, and hydrogenations of the CO. So in the ideal conditions, normally these reactions, we have the CH4, CO2, and for the ideal conditions, they are producing the CO2 and hydrogens. But this is only for the ideal conditions. However, if they are having the side reactions, they will affect the compositions or the proportions of the CO and also hydrogens. In the ideal conditions, yes, the ratio is 1, whereby you're producing 2 CO and 2 hydrogens. But after they are having the side reactions, it will affect the amounts of the CO produced and the amount of hydrogen produced. So the ratio will deviates from 0 to 1. So it depends on the catalyst used, depends on the reactions used, how the catalyst play important roles in inhibit the side reactions and favorables toward the main reactions. So normally, for CO2 forming of methane, it can be our aims is to apply at low temperature, because currently these reactions apply at high temperature. Okay, so low temperature normally the aim is lower than 400 degrees C, whereby at this as these reactions they can reduce the side reactions. Okay, in which at the higher reactions more than 600 degrees C, there are a lot of the side reactions occurred, for example, methane decompositions, and it will result in the carbon depositions, and it will result in the activations of the catalyst. So that's the current topics nowadays. They are focusing on the improving the properties of the catalyst, find this suitable support, find the suitable metal, so that the catalyst have the high main reactions and low side reactions, or but the totally zero side reactions is normally impossible, but they can reduce the number of the side reactions by improving the properties of the catalyst. So, and for these types of the reactions, the carbon formations actually it cannot be avoided, because it's thermodynamically happens at high temperature, and then it will result in the productions of the catalyst. So that's why the the improvement in the catalyst properties is needed, so that it can reduce the side reactions, it can reduce the carbon formations, and it's very important to have the catalyst that inhibit in the activations of the catalyst. And also the second one for the catalyst itself, the first the activations of the catalyst, and then because we are dealing with the catalyst that having the metals, so it's very important to ensure that the catalyst is not deactivate. And the second one, after this after the reactions, the metal is start not sintering, because most of the reactions, chemical reactions, they are using the high temperature. So for the high temperature, it will result on the metal is self-sintering. So it will become bulk, and it will reduce the activity of the catalyst. Okay. So for the improvement of the catalyst, I can say that based on the literature, there are significant trends on the improvement or developments of the catalyst. So at the previous year, at the early of the catalyst developments, they are using the monometallic catalyst. Okay, so normally they are using noble metal catalyst. So that's why when we have the applications of the catalyst previously in the industry, remember that we have the fracturing process, we have the acrylations process, they are using the platinum catalyst. So platinum is a noble metal, so the price is very high. So that's why the researcher try to find other suitable metal that in order to replace the high price of the noble metals. So in that case, the researcher used the transition metal. So the transition metals, the common one, they are using the nickels. Okay. So the previous one for the metals, monometallic metals, yeah, they are using the platinum, they are using the palladium, ruthenium, rhodiums. So this is all the types of the monometallic catalyst. And then after that, they are trying to replace the all the noble catalysts, all the noble metals with the transition metals. They are trying on the cobalt, and then ferrums, nickel, copper. There are lots of the transitions metal. They are trying to replace the noble metals. Okay, so after several research, okay, trends, and then they found that in comparisons of all types of the transition metals, nickels shows almost comparable activity of the catalyst with the noble metals. However, at that time, the advantages of the nickel's catalyst is the nickel's catalyst uh, prefer to form the coke. Okay, so that's the problems of the nickel catalyst. When the high formations of the core, it will reduce the activations of the catalyst, and it will reduce the stability of the catalyst during the reactions. So that's why when researcher replace the nickels with noble metal with the nickels, and then they try to use the bimetallic catalyst, in which for the bimetallic catalyst, they add some amount of the noble metal to the nickels based catalyst, so that they can reduce the formations of the coke or the formations of the side reactions. Okay, so that's why from here you can see that there are in a trend of the monometallic catalyst and then bimetallic catalyst, and then after the in a way of the bimetallic catalyst, they studied on the core shell nanoparticles, alloy nanoparticles, and there are lots of the catalyst trends and developments in order to improve uh, the activity of the catalyst, and also the stability and selectivity of the catalyst. So this is some intro on the recent developments of the catalyst for the CO2 reformings of methane. Okay, so from here, we have a tables. So actually, these tables is the summary of the noble metal catalyst for DRM tri-reformings of methanes in terms of the reactant conversions, yield of products. So as I mentioned before, that the early area of the CO2 reforming of methane, they are using the noble metals, okay? Noble metals catalyst. So for the noble metal catalyst, there are lots of the types of the catalyst instead of the, for example, we have the iridiums, palladium, platinums, rutheniums, rhodiums, and golds. There are type there. This is all types of the noble catalyst. Okay, so for these types of the reactions, in order to check either the catalyst is comparables with the uh, and comparables and in comparisons with the other catalysts in order for easy to compare. So normally we compare in terms of the CO2 conversion. CO2 is the reactants. CH4 is the reactant. So we compare in terms of the reactant conversions, and also we compare in terms of the yield. Okay. So here we have the hydrogen yield and also the CO yield. So this is the products uh of the of the reactions, okay? Because CO2 and CH4 is the reactant, and then the product is hydrogen and CO. So from these types of the conversions, we have two products, and then the syngas is very important to have the unity or good ratio of the hydrogen and CO. So another criteria that researcher look at is the ratio between hydrogens and also the CO. So, and these tables also compare on the stability test. They run on the stability of the catalyst. So either the catalyst stables or not, how long the activity of the catalyst remain constant per time. So this is all the stability tests that has been conducted for all these types of the catalysts based on the compilations of the research conducted by various types of the researcher. So based on the compilations of the research, we can say that noble metals have been reported as active metals for the rare reformings of catalysts. So this is at the early stage of the rare reformings of methane, and the noble metals is the very good catalyst for the reactions. And in comparisons with the noble metals, here we have a lot of the noble metals. They found that rutheniums and also ruthenium and also rhodium is, have shown to be the most active catalyst and high resistant for carbon depositions. So we have a lot of the more noble catalysts, and then after screenings and comparisons, they found that rutheniums and rhodiums is the best catalyst for the reformings of methane. However, for the upscales to industrial levels of noble metals, actually it's not feasible to use the noble catalyst because it's due to the high cost and due to the restricted availability of the noble catalyst. So that's why researcher look other alternative by using the transitions metals to replace the utilizations of the noble metal, but they would like to ensure that the activity, the selectivity, the ratio, and also the stability comparables with the rutheniums and rhodium catalysts. Okay. So after the area on the noble catalyst, the researcher focusing on the nickel-based catalyst, as mentioned just now, there are actually a lot of the transitions metals that have been tried by researcher. They try on the cobalt, copper, actually a lot. But after they compare the activity, the selectivity, and also the ratio, they found that nickel-based catalyst is much preferable because of its low cost and inherent availability. So nickels is widely available and the cost is very low in comparison with noble catalyst, and the activity almost comparable with the noble catalyst, but with some the advantages of nickel catalyst, in which I will highlight after this. Okay, so we can see that here is a tables of the comparisons of nickel-based catalyst for the reformings of methane. So we can say that these types of the catalyst, nickel-based catalyst, yes, the price is low and then is widely available for the metals and also for the nickels metals, but it suffer from the deactivations due to the carbon formations which cover the active sites of the catalyst surface and metal particles. So that's why after a certain time durations, after directions, so when the researcher compare on the nickels catalyst and also the noble catalyst, so at certain times the noble catalyst the activity is still constant, but the catalyst they found that the reactions decreasing times to time. Okay, so and the analysis of the spans catalyst showed that the nickel catalyst suffered from the deactivations. The amount of the cokes highly found on the surface of the catalyst after the reactions. So that is why that researcher need to find any suitable approach to solve the issue on the activations of the catalyst. Either they are improving the support itself, either they are adding the second metals, or they are adding any promoter to improve the nickel based catalyst, and to see the opportunity of the studied catalyst for the dry reformings of methanes. Okay, so you can see that here from the tables, they start with the singles metal oxides, and then they try on the mixed metal oxide, and then they check with the activity and also the stability, and then here they also try on the different types of the support itself. So either here they try on the audit silica, as I showed before, showed in our showed before that for the catalyst we have the support, we have the metals, and also we have the promoter. So they try to change the types of the support. Okay, so they are using the metal oxide, and then here they are using the mesoporous silica, because mesoporous silica they are having the porous structure. So when they are having the porous structure, they predict that the surface area is high, and then the distributions of the metals can be on the support and also inside the pore of the support. So for the order silica, the researcher try on the SBA15. They try to use MSN, and MSN is the nanosilica materials, and then a lot of the mesoporous silica reported in literature, for example, MCM41, and then zeolite. This is all the support types that have been reported in literature. But they also try to use the natural and also synthetic clay, because when preparing the catalyst, it's good that if the price of the catalyst is low, okay, and not too expensive, so they are trying to use the natural and also the synthetic clay to as a support, so that they can reduce the cost productions of the catalyst. So several researchers reported on the natural clay, and then synthetic clay, and also the activated carbon. This is all the types of the support materials that has been reported in literature. So they compare the activities, activity, and also the ratio. I can say the performance of the catalyst by using different types of the catalyst. So and see what is the advantages and the advantages, and they open the opportunity for the developments of the catalyst. Okay, so here is they studied on the various supports to improve the activity of the nickel-based catalyst. So here they try to use the mixed oxide, the mixed supports to check either the combinations of the support can improve the catalyst developments in terms of the performance of the catalyst towards the main products and inhibit the side products. So you can see that they have tried several types of the catalyst here, and then also different temperature. So actually for the temperature, it's good if we can try at the lower temperature. Remember that for the CO2 reforming of methane, if we conducted the reactions in the high temperature, the first one due to the cost for the energy. The second one due to the thermodynamics reactions occurred at high temperature. And then at high temperature, the metal sites it can be sinter, and then sinterings will occur, and then it will result the activations of the catalyst due to these sinterings and also the coat formations on the surface of the catalyst. So from here, we can see that researchers have tried different types of temperature from 450 to 850. So they try to differentiate the activity of the catalyst by using different types of the catalyst, different types of the different range of the temperature, and then they compare on the reactions performance. So here and also the stability, they try up to 400 hour, okay, for the stability. And they also studied on the additions of the promoter. For example, in this case, they are using the platinum as the promoter. So they would like to see either the promoter improving the activity and selectivity of the activity and stability of the catalyst. So here we can see that the additions of the platinums on nickel Al2O3 is enhance the basicity of the catalyst, generations of the metal sites, and it increase the activity and the stability up to 400 hour. However, when comparing this catalyst with other catalysts, the researcher found that the activity not too high. Okay, because the percentage activity of this catalyst, we can see that the conversions of the CO2 is almost 60%, and the conversions of the CH4 is almost only 50% in comparison with other types of the catalyst. They are having up to 90%. Okay, so so in this case, researchers still try to find suitable approach to improve the properties of the catalyst to ensure that the catalyst can be have the activity at lower temperature, but that the activity can comparables with the activity of the nobles metal reported in literature in the early era. Okay, so here we can see that there are lots of the catalysts reported on the tri-reformings of methane. Okay, so for the these types of the reactions, researcher concluded that actually there are specific roles of the types or phase in the catalyst. So for the solid catalyst, normally we will have the support, and then we will have the metals. So metals, it can be a single metals, it can be double metals or more than two metals. So multiple metals, there are lots of the research reported on different types of the metals and different amounts of the metals. So, but in general, we can conclude that for the solid catalyst, we must have the support and also we must have the metals. So metals, the roles of the metals is for the methane activations, because methane is our reactant. So the roles of the metals to convert the methane or to activate the methane for the conversions. Okay. So and also for the metals activity, researchers found that the additions of the promoter actually enhance the properties of the catalyst. So they enhance the distributions and also the interactions between metals and support. So some of the researchers found that it's good to have the promoter to enhance the activity of the catalyst. Okay. And then for the metal sides, for these types of durations, researcher found that the suitable metals for these types of directions is either nickels, cobalts, and also ruthenium. Ruthenium is a noble catalyst, so sometimes they are using the nickel-based catalyst, and then they will use the small amount of ruthenium to to improve the activity as a second metal to improve the activity of nickel-based catalyst. Okay? So and then for the catalyst, the second part is for the support, and then for the support itself, they look on the oxygen storage and also the acid base properties. So they look on the physical and chemical properties of the support. Okay, so for physical properties, we can say that it's related on the textural properties. Either is porous, either is non-porous. What is the surface area of the catalyst? So, for the support, this textural properties is very important. If the support's having the higher surface area, it will help during the distributions of the active site. Okay, and then also the properties that we need to focus is about the oxygen storage. Okay, so because the oxygen storage can enhance CO2 activations, remember for the CO2 reforming of methane, we have CO2 and CH4 as the reactant. So CH4 will activate on the metals. Meanwhile, CO2 activate on this support. So the presence of the oxygen storage in the supports actually it enhance the CO2 activations. Okay. So and also the oxygen storage also help in inhibit formations of undesired carbon depositions. And researcher found that the suitable support for the these types of directions is cerium oxide, zirconium oxide, magnesium oxide. This is all the types of the support that having higher amounts of the oxygen storage. So they will help on the enhancements of the CO2 activations. Another factor that a researcher focus on the acid-base properties because for the reactions for CO2 reformings of methane, they need to look on the acid-base properties of the catalyst because the reactant for this CH4 and CO2, then the phase of the acid and base properties is very important. But some of the researcher found that these properties must be at the higher or the amounts. But some of the researcher found that the medium strength of the basic size is preferable in comparison with the strong strength of basic side. So in conclusions, they found that for the CO2 reformings of methane, the medium strength basic size is preferable because when the basicity or the acidity is too high, it will contribute in the enhancement in the site reactions. So it's good enough to have only medium strength basic site for the CO2 reformings of the methane. So for the second one regarding the promoter such as MO and also LA, so the additions of the promoter actually they can enhance the properties in terms of the acid and also the basic. So in comparison between nickel catalyst and also nickel promoted with catalyst, the researcher found that the additions of the LA latinums enhance the properties of the catalyst, and it can help in the improving the numbers of the medium strength basic site that are responsible in the reactions of the CO2 reformings of the methane. And then the research also found that the selections of the support is very important because the selections of the support can be modified to alter the basicity. So, because as mentioned that the first point that for these types of the reactions, you only need the medium strength basic site. So the modifications of the support is needed to ensure that the 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 basic site that we have is a medium strength, not the low strength or the high strength of the basicity. And then for the types of the catalyst, solid catalyst, since we are having the support and we have the metals, so it's also important to have metal support in good metal support interface. Okay, so for the metal support interface, this metal support interface play an important role in the surface reactions mechanism. Okay, because yes, activations will occur and on the metal side for the CH4, and CO2 will occur on the support sides. But metal surface interface will responsible on the surface reactions for full mechanisms of the reactions. So it's very important to ensure that the catalyst must have a good metal support interface. And then the researcher found that suitable promoter and high metal dispersions will lead to the strong metal interactions between the support and also the metals. So if you have the catalyst of the monometallic catalyst, and then you would like to increase the properties of the catalyst in terms of the basicity, in terms of the oxygen storage, and in terms of the metal support interface, it's good to have the promoter. So promoter can enhance the properties of the catalyst, and actually it will help in the good distributions of the metal sides, and then good interactions between metal and support. So it will help in the other properties like the basic side, distributions of the active side, and thus it will increase the activity of the catalyst. So this is the general rules of the catalyst. Okay. And then, before I proceed with the second case study on the catalytic steam reformings of the biomass, so I would like to open with any questions from the floor before I proceed with the second case study regarding the first case study. Is there any questions from the floor for the first case study regarding the CO2 reforming of methanes? I'm not sure either you are familiar with CO2 reformings of methane or you are working on the CO2 reforming of methane. So if you are having any questions regarding these topics, so you can switch on your mic or you can type the questions in the chat form. So I will try to answer the questions before we proceed with the second case study. Is there any questions? Okay, no. Or Sitipon, do you have any questions? Sitipon is the moderator, right? So Sudipun, do you have any questions for the first case study? Anyone have any questions for the first case study before I proceed with the second case study? No. From my student itself, do you have any questions regarding the first case study before I proceed with the second case study?
I don't have any question, Doctor.
Okay. So if you don't have any questions, maybe we can proceed with the second case study. So actually for the morning sessions, we more on the learning a little bit about the catalyst, the catalytic reformings, catalytic reactions, and the afternoon sessions. After this, we will focus on the manuscript preparations and how to write the manuscript in the fields of the chemical reactions. So if you don't have any questions regarding the first case study, I think we can proceed with the second case study. Okay, so for the second case study, actually is about the catalytic steam reformings of biomass, pyrolysis oil, or bio oil derivative. So this one, I try to find another topics previously, more on the gas reactions in which you are having the gas as a reactant, and then you are converting gas to gas in which the reactant is CO2 and CH4, and then the reactant the products is syngas. Okay, so the second case study is you are converting the biomass to the hydrogens. Okay, so actually there are two stage biomass. We have the fast pyrolysis to convert to gas and bio oil, and then after that, either gas, bio oil, and char from the fast pyrolysis. And then after that, by using the steam reformings, normally we will get the hydrogens at the end product. Okay, so for these types of the reactions, the topics is related with the current topics related with the hydrogen's energy, because we would like to reduce our dependency to the fossil fuels. That's why the researcher try lots of research on the hydrogen's energy. Okay, because hydrogen energy is a types of the energy that can be used to replace the fossil fuels. So previously, for the dry reformings of the methanes, actually we produce the syngas at the same times if the ratio is very low, in which you can produce the higher compositions of the hydrogen. Actually, you can produce the high quality of the hydrogens from the CO2 reformings of methane. But this one is from the other approach, whereby you are using the reformings of the biomass pyrolysis. Okay, so as I mentioned that hydrogen energy will play the key roles in future energy, and actually it will make up approximately 30% of the total energy consumptions in 2025, and it is estimated that the utilizations or the usage of the renewable energy or the hydrogen energy source will be climbed up to 75% by the end of 2050. So we can see that there are lots of the good areas of research for the hydrogen energy and also the renewable energy. Okay, in current year and up to until 2050. So hydrogen fuels is normally primarily produced through the steam ethane reforming. So the hydrogen fuel produced using the steam ethane reforming. So ethane reformings etanes the raw materials actually from the fossil fuels. Okay. However, continuous utilizations of fossil fuels resource is not sustainable. That is why currently industry looking at the other sources to produce the hydrogens. Normally, most probably from the biomass types of the reactant. And fossil fuel is the non-renewables energy. So as mentioned from the first point that currently we are focusing on the renewable energy and it's expected to increase and climb up to 75% by year 2050. Okay, the third point, here we can say that the steam reformings of the biomass, pyrolysis, oil or bioderivatives can be the ones of the attractive approach for hydrogen productions. So for these types of directions, normally there are required the good catalysts to ensure that the high productions of the hydrogens at the end of the reactions. However, similar with the tri-reformings of the methanes, catalytic steam reformings of the biomass, the crucial issue is related uh, of these reactions is related on the coke depositions. So I can say based on the researcher or reported literature, the crucial issue on these topics is related with the coke depositions. So that is why that these types of directions still has restraint or not utilized at an industrial scale. Okay. Okay, similar with the reformings of the methane, since this is the chemical reactions, so chemical reactions they are having the catalyst. So the trends of the catalyst developments almost similar with the previous case study. They start with the monometallic catalyst, and then after that, they are focusing on the transitions metal catalyst. So for the monometallic catalyst, they start with the noble metal based catalyst. This is the early era of these types of the reactions, similar with the dry reformings of methane. I can say that for all the chemical reactions, for the catalyst developments, the early era, yes, they start with the noble metal catalyst. After that, the developments of the catalyst move to the transitions metal based catalyst. So here we have the noble metal catalyst, and then there are lots of the noble metal reported, and then similar, they found that rhodiums have good activity and also in comparison with the others, and it can be high stability in comparison with other noble metals. However, the price of the noble metals is quite expensive and not widely available for the applications in industrial scale. So they are moved to the transitions metal based catalyst, and among the transitions metal catalysts, they found that nickel based catalysts play good roles in the reactions and the activity and also the selectivity, almost comparables with the noble metal catalyst. But similar, the problems of the nickel based catalyst is related with the coke depositions on the catalyst, and thus it will result in the low stability of the catalyst, and therefore researchers try to use either the bimetallics or they modified the support itself, or they modified the types of the other compositions in the catalyst. So you can see that this is there start with the noble metal catalyst, and then followed by transitions metal catalyst. And then after that, they start focus on the bimetallic catalyst, since previously they focus on the monometallic catalyst. And then now they are focusing on the bimetallic catalyst by additions of the second metals. Most normally they are using the noble metal added to the nickel-based catalyst to improve the activity of the catalyst and also the stability of the catalyst. Okay. So here, and then they try to modify several they use several approach to modify the catalyst. Either they are using the second metals, and then or they are using the different support. You can see that there are several types of the support has been reported for these types of the reactions. And then similar for the second metals, they tried several types of the metals. For examples, they added the promoter serums, they added the cobalts, and then ferrum, magnesium oxide. This is all the second metals that have been tried in the literature. So they compare in terms of the activity of the catalyst and stability of the catalyst in order to find the good catalyst that having the high activity for the reactions. So here they are modifying the catalyst in terms of the types of the metals, and then similar here in which for the various types of the steam reformings of biomass, they are using different types of the catalysts, and then they compare the the characteristics of the spent fresh catalyst and the spent catalyst. either the Either the catalyst still at the original properties after the reaction, so that they confirm that no deactivations, no sintering occurred on the catalyst. So they try a lot of the catalysts to ensure the activity of the catalyst comparables with the noble metals. So you can see that in this case study, researcher reported a lot of the catalysts for these types of the reactions. So here they compose various types of the catalysts, and then with the different types of the catalyst, which is different types of the metal, different types of the support, and different types of the promoter. They concluded that these types of the reactions, these types of the sustainable reactions, uh, if we are using the solid catalyst, we must have the metal sides, we must have the support sides, and also similar, the metal support interface play an important roles in the reactions. Okay. So, for examples, metals will play roles in activations and transformations of oxygenates to form adsorbed carbon species and hydrogen. So, this is the roles of the metals. And then after that, the support itself plays roles in adsorptions and dissociations of the water to form OH group. So these reactions will be occurred on the support. Meanwhile, metal support interface will play a roles in the synergetic effects between metals and support. So you can see that metals will play a roles in activations of oxygenates. Meanwhile, support will play a roles in adsorptions and desorptions. So it's very important to have a good properties of the metals and have a good properties of the support, so that the reactions can occur uh, and favored to the main reactions and inhibit uh, the side reactions. Okay. So The researcher concluded that there are several selections on the metal and support uh, criteria. So for the metal sites, they found that the favorable activities towards steam reformings, um, WGS, and also coke gasifications. And then the metals must have high chemicals and thermal stability. This is very important because the metals is play an important roles in activations and transformations. So the metals must have a high chemicals and thermal stability so that the metals can play its roles even though at a higher temperature. So for the support itself, actually there are importance in to ensure that the supports have favorable physical chemical properties. I can say that support must have good physical properties and also good chemical properties. So here we can have the moderate basic properties. So high surface area, high mechanical thermal stability, and high oxygen storage or release capacity. So there are several strategies conducted by the researcher on the developments of these catalysts. For example, there are um, uh, changing or they are using different types of the preparations method. For example, they use the ultrasonic assisted method. They are using the reflux. They are using the um, uh, all different approaches so that they can prepare the well dispersed metals on the support so that the metals disperse homogeneously on the support and metals can play its roles in the reactions. So for the strategy for the support, researcher reported that selections of the suitable support with good chemicals and physical properties is needed because support play an important role during the adsorptions and desorptions of the water and also the hydroxyl group. So the good supports must have the moderate basic properties and high surface area. So it's good to during the selections of the support you must consider the favorable properties of the catalyst to ensure that the support will play a good role during the reactions. Another strategy to improve the activity of the catalyst for these reactions by additions of the promoter. So by the additions of the promoter, actually, it will improve the synergistic effect between metals and support. They will improve the dispersions of the metals on the support, and it will improve the properties of the support and metal interactions. Okay. So, based on the literature, they conclude that the types of the metals can be rhodium, platinum, ruthenium, iridium, and other metals. In order to reduce the cost of the productions, the noble metal can be used as a secondary metals, and the transition metal can be used as the primary metals. Okay, so for the support, they can use other types of the support. For example, the metal oxide, mesoporous silica, and actually there are a lots of the types of the support that can have can improve the properties of the support itself and thus increase the activity of the catalyst. Okay, so from this both two case study, I can conclude that for the solid catalyst, for the chemical reactions, it's very important to have the metal support and metal support interface. So for the metal support, it normally play an important roles in the activations of the metal site. Meanwhile, for the support, they will play adsorptions and desorptions of the uh, water and also hydroxy group. Okay, so it's very important to have the metal support and metal support interface to ensure the activity of the catalyst. Okay, so if I'm referring to the time itself, so actually we already 2 hours, okay, for the morning sessions. Sorry, I can't hear another voice there. I'm not sure from where.
Ganesh, please unmute. Please mute your mic.
Okay. So I'm not sure the sounds from where.
Participant name Ganesh.
Ganesh. So Ganesh, can you help to mute the mic, or Sittipun can help me on that?
Sorry, itu sendiri.
Okay. Okay, is it me? Okay. Okay. So for the morning sessions, I can conclude that for the developments of the catalyst, it's very important to ensure that you properly select the three types of the not the three um elements, which is the metal support and metal support interface, so that actually for the metal support interface, it can be improved by adding the promoter. So the selections of the metal support and promoter, actually it will enhance the activity or the properties of the catalyst. So they will play a specific roles in the reactions and enhance the chemical reactions of the process. Okay, so because the times is already 2 hours, so I think for the morning sessions, I concluded on the roles of the catalyst in the chemical reactions and then what is the, for those who are not familiar with the catalyst, I'm start with the what is the catalyst, what is the catalysis, um and also about the some informations regarding the chemical process that dealing with the catalyst. So after that, I proceed with the case study that dealing with the CO2 reformings of the methanes, and also the biomass steam reforming that dealing with the biomass pyrolysis. So that's this examples that related with the chemical reactions that using the catalyst to increase the activity and selectivity of the catalyst. So for the morning sessions, I think I already covered regarding the topics given to me. For those who are having any questions, maybe you can switch on your mic so that we can have a short discussion before we end the morning sessions. Okay, so anyone have any questions? Or if anyone don't have any questions, I'm not sure. Maybe I can pass to the moderator. Because we will have a break for 1 hour before we start with the part 2 in the afternoon sessions about the manuscript writing and publications workshop, in which I will touch a little bit on the manuscript preparations, and then maybe we can have a short discussions on the in preparations of the outlines for the manuscript, in which we can have a group activity for that. That one is for the afternoon sessions. I think for the morning sessions I already cover everything. So moderator, I'm not sure either Sutipuns or Isara available in the online sessions now. Sutipo? Sutipo not here. I'm not sure Isara. Isara still here or not? Okay, so since both of the moderator Isara and also the Sutipun's not available, and the times currently at 1 for Malaysia times is 1 p.m. For the Thailand's times, I think it's around the 12 at the afternoons. So I'm not sure, Isara, do you want to close the morning sessions? Okay, so if that case, Isara not here, I think we can end our sessions for today, for morning sessions. So we will start after at 2 p.m. in Malaysia times, or 1 p.m. for the Thailand. We will have 1 hour breaks for the second session. So with that, thank you very much, everyone.
Thank you.
Wrinkle structure. So for this one, is highlight about the preparations of the catalyst, and then the catalyst, the novelty of the catalyst because is having the tunable dendritic fibers. Okay, so that's why the author the author highlight about the tunable dendritic fibers, and the author also highlights about the radical wrinkle structure. So in the titles, you need to highlight what is the novelty of your study. And then in the abstract, you can see that the elements is similar. You must have aims, you must have methods, important result and discussions, and also conclusions. So for the yellow color is for the aims. You can see that the aims is preparing or transforming the tunable dendritic fibrous SB15. This is the aims of the paper. And then the methods, what's the methods that you are using? So either you can compile all the methods in one sentence, or you can separate it like this. For example, the preparations is they are using the microwave assisted microimmersion system. And then you also can put the method when you are highlighting the result discussions. For example, you would like to highlight on the characterizations result. So you can highlight the characterization result conducted by Y. Okay. So it can be like this, or like a previous examples whereby the examples combining all the all the methodology in one sentences. Okay. So here you can see that the blue color is for the methods, and then the green color for the importance result and discussions. So as I mentioned just now, similar with the previous examples, you need to provide quantitative and qualitative result. So for examples here, you mentioning about the higher basicity. So you need to highlight how much enhancement in basicity. So based on the calculation, 86% enhancement. So you can put the values 86%. So higher acidity. So acidity, how much enhancement? So you need to put the values. And also, it's also stated that higher thermal stability. So it must be enhancement. So how much the enhancement in thermal stability? So similar, you need to write down the percentage of enhancement. Okay, so that reader can compare. Is it the high enhancement with 90% is comparables or good enough when comparing with the other literature, or actually other literature only 5%. For this one, 90%. So reader know, oh, these types of the catalyst much better than the previous catalyst. So that's why it's very important to put the quantitative values so that it's more easier for to compare. Okay. And then the last one, you can conclude with the mentionings that the outcomes of the study anticipate the wide applications of the dendritic fibrous SB15. in catalyst and biomedics field. So you can predict, you can highlight the importance of your study in the fields, in the related fields. Okay, so if you would like to highlight on the catalyst, you just put in the catalyst and biomedicals fields. Okay, so so you can highlight the novelty of the study actually in the conclusions. Okay, so if you are referring here, actually there are similar. The 4 elements must include and compulsory include in your abstract. Okay. Okay, after we proceed with the abstract, after completing the abstract, now we proceed with the keywords. Okay, so normally keywords around 3 to 6 keywords. Okay, I think the 3 is too low, and then it's good if you have 5 to 6. 5 is good enough. 4 to 5 keywords. Okay, so should complement the keywords in the title. So normally the titles, normally you will highlight the importance or significance on the novelty of the research. So that keywords is very important, so that use that keywords uh, uh, in your keyword sections too. Okay, so for example, just now you are highlighting on the green approach, so or green synthesis. So you can put the that keywords in your abstract, the green fuels or anything that you want to highlight, and you think that one is significant enough and is novels in comparison with others, you highlight in titles, and also it's good if you can put in keywords. And then please use only established abbreviations. Yes, keywords normally keywords in one word, okay, 1 or 2 words. Let's say some can be more than 1 words. For example, the names of CO2 reforming, okay, that's 2 words, okay, but it's 1. So you can include in the keywords. But for the abbreviations, you need to check either that abbreviations is established known, or only you, not well established. If not well established, it's suggested to use the full name instead of the abbreviations. If DNA, yes, everyone knows the DNA, so you can put the DNA. But any abbreviations, let's say other types of the abbreviations that not publicly well known, so better you use the full name. And then avoid to use and of. For example, dry reformings of methanes. Yeah, we know that is a 1 sentence, but please avoid because that's quite long. So make it dry reformings of methane. You can do some shipments, methane dry reformings like that. Okay, or maybe you can put the dry reformings. So try to find the short keywords, okay, that that represents the contents of your manuscript. Okay, so let's see these examples. These examples, the titles about the greenhouse gas mitigations and hydrogen generations via enhancement and ethylene glycol dry reformings on LA promoted COAL2O3 catalyst. So we can see that the reactions used in this study is ethylene glycol. So you can put ethylene glycol as a keyword. And then you can see that it's would like to highlight about the LA promoter. So you can put the LA promoter. Or you can put the latinum. Okay. So and then the catalyst is the CO cobalt Al2O3 catalyst. So the name of catalyst is better you put the cobalt catalyst or cobalt. Don't put cobalt Al2O3. That's not it can consider as abbreviations, but it's good if you can make it more general. Okay. And then this one is more on the hydrogen generations. So that's the products is hydrogen. So put the hydrogens here. And then the reactions is dry reformings. So you can put the dry reformings, or dry actually is represent CO2. So, or you can put the CO2 reforming. So normally the titles and keywords actually highlighting the same element. Okay, so you can refer to your titles, find the suitable keywords for your mainstream. Okay, so let's proceed with the graphical abstract. So graphical abstract is actually summarize the contents of the articles in concise pictorials form designed to capture the attentions of the wide reader online. So normally, if if you go through the Sign Direct, the Wiley publisher, Springer publisher. So when they are listing the list of the published articles, they will put the graphical abstract. So it's very important to prepare the attractive, concise, that representing the contents of your manuscript, because it will attract the reader attentions. Okay, so that one is actually is normally sometimes is optional or compulsory depending on the journals. So you need to check the guides for the journals. If the graphical abstract is compulsory, you need to prepare the graphic abstract. But it's optionals. It's good if you can have it, because the graphical abstract represent the abstract or the contents of the manuscript in a picture form. So it can attract the reader interest to read your articles if you can prepare the graphical abstract properly. Okay. So for examples, it's good to have the graphical abstract that represent the contents of the manuscript. For examples, we can see here we can see that the contents of the manuscript start with the preparations of the materials, and then they proceed with the characterizations, and then they proceed with optimizations. We know that this manuscript focuses on the preparations of the materials, and then it's optimizations toward the photo degradations, if I'm not mistaken here. Okay, so you can see that the graphical abstract represent the contents of the manuscript. Okay, and then this and also the graphic abstract is quite interesting, and actually it can attract the reader to read this manuscript. Okay, the second example is the right side. We can see that the picture of, okay, the left side, we can see that that's the catalyst. So that the catalyst having the reactions. So the reactions on the surface of the catalyst, since the catalyst the molecules is very small, so they make it emphasized. Okay, so you can see that how's the reaction. So we know that this paper presenting the materials, they prepare the materials that having the fibrous morphology or tunables morphology here, and then there are the materials having the reactions, and then we can see that what types of the reactions conducted. So this is another interesting graphical abstract that concise, and it represent the contents of the manuscript. Okay, so for the research highlights, so after the graphic abstract, you will have the research highlight. So for the research highlight, it's normally 3 to 5 bullets point. Okay. So, and then please remember that each point must consist of about 85 character only. Don't make it too long, because it's already stated in guide for the author, research highlight, must consist of about 85 character, and the points around 3 to 5. Okay, so please choose the important element that you would like to highlight in your research highlight, because it's very limited 3 to 5 point only. And the second one is good if you can highlight the result oriented points and you only highlight the main findings, because yeah, your manuscript have a lot of the findings, but for sure your manuscript has a significant findings or the main findings. So for the research highlight, only put the main findings, and that main findings result oriented point. Okay, and the third one cover qualitative and quantitative findings. So it's good if you're highlighting about the increasing or excellent activity. So put the values. Maybe the values is 99%. Yeah, put the values. So we know that your catalyst can perform the activity up to 99%. So you will attract the reader to read your manuscript. Okay. So these the examples of the research highlight. You can see that it in a short form, and then is highlight on the importance elements. So we can see that it compares several types of the catalyst, and then you would like to make it in sequence, increasing activity, decreasing activity. You can put the catalyst. And then what is the favorable properties of the most significant catalyst? So you can highlight what is the important physical and chemical properties, and then if they are having the specific trend and is interesting to highlight, and is a that new findings that in comparison with literature, yes, you can highlight in your research highlight. Okay, so this is the examples of the research highlight. Okay, so let's proceed with the introductions. Okay, so for the introductions, here I summarize the way, the normal way that myself and my research team prepare our introductions part. Okay, so you can see that for the introductions, is that you can provide a brief context to the reader or background of the study. So you can start with the background of the study, so that for those who are not familiar with the topics, so when they read the background, they know about the topics. Okay, don't start with too specific, because some of the reader not really familiar with the topic. So it's good if you can start with maybe one sentence of the background, so that you can highlight the brief context, and you can provide the brief context to the reader. So for this one, you can normally the introduction sets the scenario, the brief context of the topics. Okay, and then the second one is you address the problem based on the literature. So for this one, actually, yeah, there are lots of the literature, there are lots of the published articles, but don't attempt to summarize the whole field. Okay, so you need to find the most resembles with your topics, most similar with your topics, that can highlight the problems in your the problems of the research. Okay, and then the third one, after you highlight the problem statement that address from the literature, you can find the gap in literature. Okay, so you address the problem, okay, and then you can highlight, okay, this based on the literature, it there are lots of the gaps or lack or no study reported in this field. So you need to find the gap in literature, and what is your motivations to do the research? what is the gap in the knowledge. Okay, for example, let's say you are dealing with the catalyst, okay, and then no one study on the mechanism for that reactions, but it's very important to know the mechanism so that you know how the reactions path, and then how to improve the reactions, in which after you know the mechanism, you know which one is the importance element to improve in your catalyst. So for that one, it's very important to find the research gap first, and then you can highlight that your study actually fill the gap. Okay, so for the fourth one, after you finding the gap in the literature, you highlight what is the lack of uh, from the literature, and then you identify the solutions and limitations. Okay, and then you highlight why is your approach different or better. Okay, after you find the gap, so you can say that this study can identify or something. This study, because no literature reported on the mechanism, and the mechanism is very important to identify the roles of each element in the catalyst. So thus this study proposing on studying the effects or studying the role of each element in the mechanism of what. So you need to identify the solutions and limitations, and highlight why your approach different or better, and how do you plan to fill the gap. Okay, and then the last one, after you identify, you can fill the gap, you can introduce your works. Okay, these works you finding the you studying the mechanism, and then the mechanism conducted using which approach. So you can introduce your work, highlight the novelty and the importance of the study. So normally the introductions of your work and highlighting the novelty normally put at the end, so that it give the key idea to the reader. Okay, so this is the problems, and then this is the gap, and your method or your approach can solve all the problems highlighted in the beginnings of the introductions. So this is the brief concepts on how to prepare the introductions. Okay. Okay, so for the next one is related with the methods. Okay, so for the methods, it depends if you are dealing with the simulations, the methods discussing on the simulations that you conducted. If you are dealing with the experimental procedure, so methods will explain the experimental procedure. If you are dealing with the survey, so you need to explain the method for the survey. Okay, so the way how to write the methods is, the first one, you need to describe how the problems will be studied. Okay, so for examples, if you are preparing the catalyst, okay, you need to write down how you prepare the catalyst. If you deal with the chemicals, what types of the chemicals used, and then what's the volume, and then what's the purity parents of the chemicals. You need to provide source and related product informations, including the company, molecule weight, and etc. For examples, if you are dealing with the acid, okay, and then an acid, the brand is from the sigma altris or from the milk, and then what is the concentrations, you can add the concentrations info, or you are dealing with the purity, you can add the purity info. So you need to provide all the importance info of the product. Okay, and then include the detailed informations if you are dealing with the for examples analysis. Okay, you do the analysis by using the nitrogen adsorption desorptions. So there are specific procedure that is there any treatments conducted before the hydrogen adsorption process, and how long, if there is a treatment, how long the treatment was performed, what's the temperature, what's the time durations conducted. So you need to write all the informations. If you are dealing with the nitrogen hydrogen adsorption desorption and you deal with the flow of the gas, so yeah, you can need to provide what's the gas that you are using. So you need to write down all the informations required in your manuscript. So the third one, do not describe previously published procedure. So for example, this procedure originated from previous published articles. Okay, so no need to write the detailed procedure. Is enough if you can write it as the method, the preparations of A according to the method described by Ali et al. Okay, so and then in brief, you can summarize the procedure. In brief, the preparation start with the microemulsion method, followed by introductions of this one, and then heating and drying. So make it short informations, since the detailed method already published in the literature and you already cite those literature in your manuscript. So the reader will read the procedure that you have. If they would like to know further in terms of the details about the specific volume, about the time, temperature, all the details informations, they can refer to the cited articles to get the detailed informations. And then the number 4, for the methods, you need to identify the equipment and describe materials that will be used. So as I mentioned just now, if you are dealing with the equipments, so provide the info of the name of the equipments, okay? And then models of the equipments. And then if it's good, if you can write a short info, the the purpose of the equipments. For examples, let's say the nitrogen adsorptions, desorptions, you in bracket the number of the brand or models is used to study the textural properties of the catalyst. So we know that you use the equipment to run the analysis of textural properties of your catalyst. Okay, so and then disrupt materials that will be used. So for the materials, as I mentioned just now, if you deal with several materials, don't forget to write down the names of the materials, the volumes of the materials, and then if you are dealing with purities or concentrations, so you need to write down all the informations there. And then for the methods, method may also include flowchart and experimental setup if your procedure is quite complicated and you think that by writing in the paragraph form, because a lot of the step there, the reader is quite difficult to understand. Okay, so it's good you write in the text, but you can put it as the methodology is summarized in flowchart figure 1.2, so that the reader can go to the flowchart and then they can read together a flowchart and also the descriptions you mentioned in text to enhance the understandings of the procedure. Because if the procedure is simple and only a few steps, is okay. You write it in a paragraph forms or in a sentences. But if you are dealing with the lots of the procedure and the procedure is very tricky and very too many, okay, and then sometimes it's back again, So it's good if you have the flow chart so that the reader more understand the process. And if you are dealing with the reactions, sometimes for the reactions you need the director. Okay, the writer that you have sometimes difference with the other researcher writer. Maybe you do some modifications for the improvements of the writer setup. It's good if you can put the experimental setup in your manuscript. But remember, instead of you just snap a figure that set up in a lab and then you put the figure, it's good. Please do a schematic diagram. Draw a schematic diagram, the setups of the reactor, and then make it more presentables and easy to understand. So you can put in the methodology sections of your manuscript. And then you also can include the tables of experimental conditions. So for this one, normally if you are dealing with several experimental conditions, okay? So for example, your experiments up to 24 experiments, right? A lot of experiments. So when you read in a text, lots of the number is quite difficult to understand. So it's good if you can make it in tables form. I can say that if you are dealing with the response surface methodology for the optimizations, you or the statistical, you have the number of the set of the experiments. So it's good you make it in tables, so reader know that all the experimental conditions of the experiment, sets of the experiment conducted as listed in the table. So this is all the informations that you need to add in your method sections, okay? And then for the result and discussion, okay, so I divided into three important elements in the result and discussions. The first element, you must have the result, okay? So how to present your result? You need to have to be clear and easy to understand. Make sure your result be clear and easy to understand. Okay, and then provide only meaningful data. Yeah, I believe that some of your data is a raw data. So that data need to do some critical analysis. So you need to analyze first, and the analyzed data with the graph you include in your manuscript, not the raw data. Okay. So please be careful which one is the raw data, which one is the analyzed data. So only provide analyzed data in your manuscript. The third one, include illustrations and figure. Okay. So for the experimentals, for example, you deal a lot of that set of the data. Okay. So in order to make more presentables, you can plot in a graph. Okay. So you need to check either the data that you have better present the data in the forms of the figure or in the forms of the tables. Because for the result, you can have both figure and also tables. But it depends on the data. Some of the data suitable in the figure, some of the data is suitable in the forms of the tables. Okay. Okay, so you need to have the result, and as mentioned earlier, that please have the specific numbers of the figures and tables only. Don't put too many figures and don't put too many tables. If you have a lot of the figures and the tables, bring it to the supplementary data. Only significant figure, only meaningful figure and tables put in your main manuscript. Okay, so then regarding the figures and tables, please ensure that your figures and tables easy to read, maximize space. Okay. especially for the figure. Please ensure that all the font of size of the text inside the figure is readable. Okay, so because that reader will refer to the figures to check your result. So when the figure is too small and not readable, it's very hard for the reader to understand your findings. And then please consistent formatting between figures. Okay, for examples, you have 5 figures. Some figure is too small, some figures is too big, some figures in a moderate size. So it's good if you can set the figures in what size. In the maybe 5 to times 10. You standardize all the figures, so it's more good in presentations, and then it's more consistent in formatting between the figures. Okay, and then the third one, raw data should not be included. This one similar with the previous point that I mentioned. Only put the analyzed data. Okay, so only put the analyzed and calculated data. All the raw data not required to put in your manuscript. Okay, that's used for the calculations to get the analyzed figure. And then the last one, for the figures and tables, please make sure that it's self-explanatory, captions and legend clear, take home point. So for this one, please ensure that you have a figure. And then, of course, your figure and tables must have a titles or captions. So for that one, please make sure that the captions and the figures have an important point that clearly represent the figure. So for examples, figure 1, I can see that SRD patterns of catalyst A and catalyst B. Okay? So it's clear, catalyst pattern, SRD patterns. Instead of you are just put catalyst A and catalyst B, but we don't know, is it for what's data that you are presenting? If you are put the SRD pattern, so what's the catalyst that or the samples you analyze? So write the informations, clear explanations in your legends. And sometimes regarding if you are dealing with the reactions, so it's good if you can provide the conditions of the reactions that you are the reactions conditions in the captions. For example, you are presenting the catalytic activity or catalytic stability. So for that one, it's good if you can put the conditions of the reactions. Okay, so you can put, let's say, temperature. What's the temperature? Catalyst dosage, pressure. So when the reader would like to compare your data with the other published manuscript, they can simply know the comparisons of this figure and another figure based on the reactions conditions. Okay, and then this is for the figure and tables. And for the discussions, please make critical interpretations of the result. Okay, don't make it too general. You just explain the activity increasing from 0 to 30 minutes. Okay, so you need to critically interpret why. Okay, why the activity increase, and then does the increasing of the activity similar trend with the other catalysts? Okay, so you need to critically interpret the result. And then the second one, make the discussions correspond to the result. Okay, make sure what you are writing in the text, okay, similar with the trend in the result. Okay, for example, the result, you show that figure 2 shows the SRD of the catalyst. Okay, from the SRD, there are 5 peak observed at the values of what you put. But the mentions value that you stated in the text not similar with the labels values you put in your figure. So it's contradict. Okay, so please check all the informations given in the figure similar with the discussions you mentioned in text. So, and then the third one, do not make statement unsupported by your data. For example, you just only make statements based on your opinions, but your data in a contradict way, or you don't have that data. For example, you are saying that catalyst A having high surface area in comparison with catalyst B. But in your result and discussions, you don't have any BET data. So where you get that statement? Okay, so don't simply make any statement without any unsupported data. The last one regarding this discussions is compare your result with the published result. So that's mean if your trend is increasing, okay, the conversions of the reactants increasing from 10 to 15 minutes, okay, so you explain this is because of what, okay, and then you can put the result is in line with the study reported by Chin et al. For the activity using the catalyst of what. So we know that actually the trend is common. The common trend that you observe in your catalyst in your study already observed by the literature, and the reason that you predict align the reason that stated in literature. So we know that actually no contradicting informations. Okay, so that's very important to compare your result with the published result. Okay, so here I put some result and discussion examples. Okay, so the left side, you can see that this is actually the ammonia TPD result. Okay. So normally, when you get the data for ammonia TPD, the data only the black color, okay, only this one. So that's called as a not unanalyzed data when you just put the noise pattern. In this case, you can see that the ammonia TPD profiles, the author include the deconvoluted peak. Okay, you can see that the line, the red line, and also the blue line. So this one is called as the analyzed data. They analyze the data. Okay, so here, since this study compare 6 samples. So it's good if you can compile all the data in one big figure, or either you separate the figure like this, you can make it scattered. So that's mean you can combine all the figure in one figure. Okay, so that one also can. So this is the figure that you have, and then this is the qualitative data where you can get the info of the peaks of this one higher than the peaks of this one, but you still need the quantitative data, how much the differences in the increments of the peak. So that's why this author add another tables, so they put the values here so that more easier to compare. For example, the first peak, the first peak and the second peak of the first peak of this catalyst higher than the second catalyst. So but we need to know how much the increments value, so that's why I need this table. Okay, so another one for the result discussions, you need to write it, start with the intro. What I mean as an intro, you need to introduce your tables and figure. For example, the convolutions result are shown in tables 2 and tables 2 and figures 2. Or maybe you can write it as a figure 2 and tables 2. Compile the data of the ammonia TPD of what result, what catalyst. So you explain the you mentions the figure first in your text. And then after that, you explain your result. What's the result that you get from the data that you have? So you just explain the result, and then after you explain your result, you can explain on the increment, the decrements, the overlap peak, how many peaks that you have. That's the result. The critical discussions you need to discuss. Yes, you have 2 peaks. What's that 2 peaks? So yeah, you have the increment in the intensity of the peak. So what's the reason behind that? So you need to include the info in the critical analysis and also the discussions. So this is all the discussions of the result in table 2 and figure 2. After you put the critical analysis and discussions, you can conclude, you can end the paragraph by comparing the result with the literature. So you can put here, here they compare literature and then they highlight this one in agreement with the findings in literature. So you put the citations. So we know that the findings from your study align with the literature. So we can expect the reasons that you mentioning just now similar with the reasons explaining in the literature. So that's the common phenomenon. Okay. So this is the good way to write the result discussions, in which it must consist of the intro, result, critical analysis and discussions, and you compare with literature. And then remember how to boost your result and discussions, because we don't want to present your data in the normal way, because too bored. Okay, so people will bored when they see the similar figures from all published articles. Okay, when you submitted the manuscript and then the review found that the figure is almost similar with the published articles. What are the differences? So it's very important to make sure that you have a data, and then you need to analyze the data, and you need to boost your result and discussions by providing the analyzed data. As mentioned just now, don't put only the black noise peak. You need to provide the deconvoluted figure. And then you need to compare with other samples. How many samples that you have? 6. So you need to provide all the 6 samples. And then for the discussions, you need to provide, observe the changes, discuss what's the changes observed, and then justify the observations, and at the end, compare with literature. So you can boost the discussions and the result that you have. Even though the method that you use, ammonia TPD for the catalyst is actually the common analysis for the catalyst. But the way you present the data differs with the others, so you can attract the editor, you can attract the reviewer to read your articles, because it differs from the others. Okay, so try to boost your result and discussions, make it interesting and different from the others. Okay, and then this is some examples on how current researchers try to make boost their result, in which they are be creative to present. You need to be creative to present your data and be up to date. If you don't have any idea how to make your figure and also the tables in a creative way, you can read the current articles. Okay, so that you have an idea what is the current way to represent the data. Okay, what's the types of the figures that's suitable to represent your data. And then you also can correlate the result with the activity performance. For examples, okay, for the samples one, you have, this is the common data. Okay, this is the common way of presenting the data. You have the data and then you put it or you overlap in one figure. That's the common way. But it's interesting if you can make it the convoluted figure and then you separate it like this. So we know that all the figures, all the samples have a three peaks, and you can see the differences in the area of each deconvoluted peak. So this is more interesting in comparison if you put like this. And then you also can correlate because you are dealing with the catalyst. So catalysts have the properties, physical and chemical properties. So you can correlate the properties of the catalyst with the activity of the catalyst. Make it in one figure. So we know that you can summarize that which properties that correlate directly with the yield of the product. Okay, so is there any properties that actually not correlate with the activity? So you can discuss when you compiling the result of the activity with the results of the characterizations analysis. Okay, this is the another examples of the creative way to draw the figure. And then this one is another samples in which the author write the relationship between the yield of the products, and then actually there are having the three types of the products, and then they observe that actually the acid sites play important role in the reactions, but they don't know which types of the acid site, because for the acid sites we have the weak acid site, medium acid site, strong acid site. So it's good if you can compare this graph. You do the summations of the types of the acid site, and then this is the reactions. So we can see the correlations. If the increasing in the activity, is it the similar trend increasing in one types of the acid sites, or is it in a contradictory way? So you can correlate the properties in the acid sites and also the activity of the catalyst. So this is the another examples to boost up the data that you have. Okay. Okay. So so we proceed with the conclusions. So after you have the result and discussions, and then you boost up the data that you have, and then you critically analyze the data. So then you need to have the final part is the conclusions. So conclusions normally is highlight the result and findings of the study. It's reflect the originality of the work. So you need to highlight the result and findings of the study. So what is the importance of your study? What is the significance data that you have? And then you need to highlight the originality of the work. Okay. So the second one, and then summarize achievement, or you can be consistent with objective. So as mentioned the introductions, this is your objective, and this objective fill in the gap as mentioned in problem statement. So in conclusions, you need to highlight that the result that you have consistent with the objective mentions in the introduction sections, and you successfully achieve all the mentioned objective in the in this study. Okay, so you need to focus on significance or importance. Only don't summarize or compile all the result that you have in conclusion. Just highlight the significance or the importance of the result that you have. So for the last part is good. So if you can conclude and you suggest the future works or the importance of this study in the fields of the research. Okay, so you can sum up with one conclusion, one future work or conclusions at the ends of your conclusion sections. Okay, so this is the conclusions. Okay, so after the conclusions, you will have the acknowledgement sections. For the acknowledgement sections, you need to acknowledge your research grant, financial support, and also the scholarship. So if you have normally your supervisor or that study granted by your university, by your ministry. So you need to provide, acknowledge the financial support by writing the specific names of the grant. And then if you are having the scholarships, okay, most normally for the postgraduate students, if you are having the scholarships, so you can acknowledge your scholarships in your acknowledgements by providing your the scholarship to you. Okay. And then the second one, you also can appreciate support, discussions, measurement from other contributor. So if you have contributor for your study, and that one is that contributor not as your co-author, so you can put in the result discussions. For examples, you have a connections in University A, and then your connections help you in analyze the samples. Okay, analyze the samples, and then you can put in the acknowledgements that you acknowledge the Professor A in helping analyzing the data of what. Okay, so you can put in the acknowledgement. But remember, for those you acknowledge in the acknowledgement sections, please make sure that those not as a co-author of the manuscript. Okay. So and then the manuscript normally must have the references, must follow the guide for the author. So each manuscript has their own guide for the author. So you need to refer to the guide for author, because some of the manuscript using the numbering system, some of the manuscript using the naming system. So you need to check the guide for the author to identify the correct reference format. And then please use the recent publications, normally within 10 years. So currently, however, lots of the publications right now, we can see the trend increasing publications in our field. So you can put within the 5 years is already enough. No need to up to 5 years, because the recent trend on the topics significantly increasing by year. Okay, so please avoid excessive self citations. Okay, if it's compulsory, yes, you can put your paper or you cite your paper, but don't make it too excessive. Okay, please avoid it. And then avoid excessive citations of publications from the same regions. For examples, you are from Thailand, and then please avoid to have excessive citations or the paper from the Thailands. So make it the origins of the article that you cite around the world. Okay, so this is the formats for the references. And then supplementary data, I would like to highlight that supplementary data is not compulsory, but if you have extra figure, extra tables that you think that is very important to include, but it's not in your main manuscript. So for that one, you can put it in supplementary data. And then actually another options to reduce your number of the figure and number of the tables, because you have a limitations number of the figure and tables. So the extra figure and tables, you can move to the supplementary data. And then please make sure that you need to comply with journals rules and formats. So some of the journals has the formats and rules for the supplementary data. Please refer to the guide for author to follow the rules. And then in the manuscript, how to refer to supplementary data actually is almost similar with how you refer the figure and tables in the main manuscript. For example, in your manuscript, normally you highlight figure 1 shows. Okay, so the difference is the figure in the main manuscript normally you put as a figure 1, but if the figure in a supplementary data, you will put the S in the beginnings of the number. So you can put S1, figure 1, S2 for the supplementary figure 2. So for the tables, similar table S1. So we know that if the numbering is figure S1, so we know that the locations of the figure or tables that you referred located in the supplementary data. So this is how you can refer to the supplementary data of your manuscript. Okay, so to conclude that for the preparations of the catalyst, for the preparations of the manuscript in the field of the catalyst, I can say that this is not the fields of the catalyst only. In the all fields, this is the general informations. Please consider the following aspect, because the following aspect must be taken into account. So the first one, pay a specific attention to the general instructions for author, because different journals must have different instructions. Okay, so you need to read carefully what's the importance element, what is do and don'ts in the guide for the author. So please refer to the abstract and keywords. For example, abstract, what is the maximum words for the abstract? Keywords, how many keywords for the keyword sections? It depends on the journal. Some journals mentions up to 5. Some journals can mentions up to 5. Similar with the abstract, some journals mentions can be up to 250. Meanwhile, some journals mentioning only up to 150. So please refer to the guide for author to check the maximum number of the words in the abstract, and then the structure of the manuscript, the tables formats and the figure formats of the data, and then the length of the manuscript. As mentioned just now, there are specific length for the research articles and specific length for the review articles, but the maximum length depends on the types of the journal. So please refer to the guide for the author. And then similar for the references using different format depends on the journals. Either it's APA, Chicago, either it's naming or numbering. So it depends on the journals. Please refer to the journal guide for author. And then the second one, please read the journal scope carefully. Okay, so different journals will have different scope. Okay, so please read the journal scope carefully. If you will get wrong about this, your paper will be rejected at the initial stage. Okay, you just waste your time. So please read the scopes of the journals, and please ensure that your manuscript align with the scopes of the journals. And then focus on quality rather than quantity. Yeah, you would like to have a lots of the paper, lots of the publications, but please focus on the quality first instead of the quantitative. Okay, and then look out for English. This is very important because a journal editor dislike bad written manuscript. So for the once your paper submitted to the journals, technical team will check if the English is not good, not readables, they will reject it on the spot. But some of the journals, they will pass with the with the editor, and editor will check and comments. So if the editor found any spelling error, any formatting error, grammatic error, and actually the editor very dislike about this one. So once editor found about this, automatically your paper will be rejected. So please check the format, please check the spell regarding the spelling and also the English if you are not expert in this one, because we know that English is not our native uh, uh, language. Okay, so that's not our language. So yeah, you are from Thailand, you have your own language. Me from the Malaysia, I also have my own language. So it's good if you can submit your manuscript to the English proofreader. So let the proofreader do their task to check your manuscript and improve in terms of the English of your manuscript. And then during preparations of your manuscript, after you completing your manuscript, when you would like to submit your manuscript, actually you need to prepare the cover letter. So for that one, you need to emphasize the paper originality and novelty. Also point out its potential interest to the journal's reader. How your manuscript can emphasize the or what is the novelty of your manuscript, and how your manuscript can improve the developments of the specific area in that specific knowledge in that area. Okay, so you need to emphasize and point out in your cover letter. Okay, so actually I have some class activity, but based on the times, I think it's already reached 2 hours, because supposedly we stop at 3 p.m. Thailand time. So actually we only have 7 minutes. So for this one, actually I will for the class activity, I would like to ask the number of the group, but here the number of participants only 9. Maybe you can discuss with your friends. It's good if you can the slide will be given to you, so maybe you can have a good class discussions with your friends on identifying the topics and outlines for the manuscript, so that you know what is the importance element in the review articles. If you are focusing on preparing on the review articles, you can have the outline of the review articles. If you are preparing the research articles, you will have the outlines of the research articles. So actually, my slide, I also include some examples of the manuscript outline, so that after this I will share my slide with the Isara, so Isara can share with all of you the slide, so that you can go through the class activity. Okay, so Isara, that's all from me. Maybe you can open for Q&A, or it's up to the moderator how to arrange the discussions. I'm not sure if Isara is here or not. Isara, are you here? If not, Isara, Sutipong, are you here? Either Isara or Sutipong, can you switch on the mic? Maybe you can respond. Or anyone from the PSU or from the UMP, do you have any questions? You can switch on the mic, or you can write down some questions in the chat room, so that I can read before. I'm waiting for the Isara and Sitipong's reply. So any questions from the floor? So basically you can switch on the mic, or you can write down in a chat box. So based on the attendance, I'm not sure is that anyone from the PSU? Is there anyone from the PSU? Maybe you can switch on the mic. I'm not sure. Is it Kimananda? Kimananda, can you respond? No. Isara, can you respond? I'm not sure. Either I should end the sessions or what? So let me stop share. Okay. Okay. So either Isara or Sitipong, anyone would like to respond? I think most of the attendants from the UMP itself. Adi Azmai, are you from UMP? I can see the attendance the names of the Adi Azman participants? No, no response. Okay. Okay. So since the organizer is Sarah and Sutipons also not response. Okay, we have questions here. Wait. Okay, so Bashi mentioning thank you for the presentations, welcomes. And then Siti Nur Koratulain, Doctor, based on your experience, what is your biggest challenge when submit the paper? Okay, so for the biggest challenge, okay, I can say that for the catalyst developments, the trend, the developments in the catalyst, the trend is very rapid. Okay, yeah, for examples, I'm currently dealing with the fibrous materials. So previously, yes, that one is a novels one, so easier to publish. But currently, the trend is very rapid, and a lot of the research group doing the same types of the catalyst. So I can say the difference is previously more easier for me to publish, but the currently I need to critically analyze my data. As I mentioned just now in my slide, the ammonia TPD, the SRD image, the activity of the catalyst, the graph is the common way in which all the catalysts will conduct these types of the analysis. So you need to do the critical analysis of the data that you have. So for examples, if you have the ammonia TPD, so normally I will ask my students to do a creative way in presenting a data. Maybe we have the characterizations data, and then we also have the catalytic activity data. So at the end of the result in discussions, we will see the correlations. We will see the effects of the roles of the catalyst in the reactions. So I can say that the biggest challenge is currently there are lots of the researcher in the fields. Okay, the trends in the developments of the catalyst very rapid. Okay, if you are late a little bit, actually there are lots of the researcher do the same things. They will publish first. So if you are late on that part, so most probably their research will be published and your paper will be rejected. So in that case, you need to align in a par with the other researcher, and your phase, your speed align with other researcher. Try to make it fast so that the idea that you have in the topics still relevant in when you plan to submit your manuscript. Okay. Okay, am I answering your questions, or you have any other questions?
Thank you, Doctor. You answered my question.
Okay, so for the others, any other questions before we end the sessions? I know. Okay, so I would like to check again. Any here we have Isara or Sutipo? Okay, no. Okay, so if that, I would like to say thank you very much to all the participants that joining these sessions. Okay, so for the PSU participants, I will share the slide to the Isara and Sutipong. So after this, you will ask them for the slide for the UMP participants. I will share to my students. So if you would like to have that slide, you can ask my students, or you can directly email to me so that I can share the slide to all of you. So with that, I would like to say thank you very much for attending this seminar or workshop. Actually, this seminar is organized by PSU. So it's a visual exchange program between the PSU and also the UMP. So thank you everyone for joining this meeting. So hope to have all of you again for the next seminar and workshop together with the PSU. So thank you everyone.